this is a pattern, right? We've been studying patterns this whole chapter, so that's why this is at the end of this chapter, this proof by induction, okay? If I had this pattern 1, 1 plus 3, 1 plus 3 plus 5, 1 plus 3 plus 5 plus 7, we could look at the sum of this, and if I added this up, it would just be 1. Do you agree with that? If I added this up, 1 plus 3 is 4. If I added this up, 1 plus 3 plus 5 is 9. If I added this up, 1 plus 3 plus 5 plus 7. What we like to look at is there a pattern in the sums of these terms? And so they just said, well, what if we wrote this sequence out? 1 plus 3 plus 5 plus 7 plus, and then this is just like the nth term, right? Like if I plug 4 in here, 2 times 4 minus 1, I get the fourth term, which is 7. So this is just like what we've been doing. What do you think? What does this look like?
Pattern.
A pattern of like 1 squared, 2 squared, 3 squared, 4 squared. So it kind of looks like that it's the nth term squared. So it looks like this sum adds up to n squared. So if I wanted the sum of the first 10 terms, it seems like I could just take 10 squared and that's what would add up to. This is what appears to happen. But we're not allowed in math to just jump to that conclusion and say, well, it worked for the first 4 terms, so it must work for all of them. In math, we have to prove it. So that's why we do proofs in geometry, not to make your life miserable, but it's because in math there are proofs, because you have to prove things that are true. And the same thing is true for these patterns. So, there's this guy, this famous guy, Fermat. We don't say the T. Fermat's last theorem. It's called Fermat's last theorem, so I don't know that that would be a just
last theorem. Like, did he die after this?
Well, he died before he proved it, if it was true or not. He said, for any number, if you took 2 to the 2 to the n, so that's kind of weird, right? 2 to the 2 to the n, like that's like a double exponent, and you added 1, he said it would always be prime. And he tried to prove that, but he died before he proved it. I'm going to look up some of these numbers because they get really big and I don't know where it's from. But you could plug 0 in there. What happens when we plug 0 in?
2, 2.
Plus 1. Is that a prime number? Yeah, no, that works. Oh my gosh. If we plug 1 in there, we would get 2 to the 2 to the 1, which is 4. 4 plus 1 is 5. And I'm just going to tell you the other ones, it's not so bad here. And then you get 17, and then you get 257. And for each of these numbers, which 3 and 5 and 17 are easy, but for each of these numbers, he had to prove that they were prime numbers, that there's not any number that goes into them. So you can see what happens very quickly. You get 65,537, which turns out to be a prime number. And then the 5th term in Fermat's last theorem is 4,294,967,297. And so he died before he could just figure out whether this was prime or not, because he had to see is there any number that goes into it. And actually, our other famous guy here that we talked about a lot, look at my smartboard. Series.
Yeah.
I did. He didn't even.
Are you writing eulogy? Is that what word is?
No, Euler. Remember Euler, our math guy? No. I'm just going to sit over here.
I thought you were going to stop.
This guy, Euler, he proved that this is not true. It's Euler. It's Euler talking. He proved that the 5th term is actually factored into 641 times 6,700,417. So after Fermat died, he proved that his theorem was not true. And so that's one of the reasons that we have proof. I know it doesn't make you like proofs any better, but that's why we have proofs, because you can't just make a conjecture and say this seems true. It worked for the first few terms, so it must work all the time. So that's why we have proof. The proofs that you did in geometry, you don't really need a calculator today. The proofs that you did in geometry were like the 2-column proofs, where you have your steps and your reasons, just very much like saying why each step is true. You also did paragraph proofs. Today I'm going to show you a new type of proof of how to prove a pattern is true. Okay, so it is called mathematical induction or proof by induction. And basically there are 2 steps, and they're kind of very abstract. That's why people don't like it very much. But basically, they give you some statement about some pattern involving some integer. And we can prove step 1. It's the easiest step to do. Even if you do nothing else on your test, I bet you'll do step 1 and you'll get a couple points. But we're going to prove that the pattern's true for the first term. So we just plug 1 in for n. That's easy. But then the second step is we want to say that the truth of p sub k implies the truth of p sub k plus 1 for all values of n. So basically we're going to change the n's to k's. We're going to look at what happens if we look at k plus 1, and we're going to show that they equal each other. It's very step by step, so if you just stay with me, it's not the worst thing in the world. I think it's better than geometry proofs, because in geometry proofs, you didn't always know what to write. You didn't know where to go. And these, it's the same steps every time, and it just changed numbers on you. There are some questions on your homework just practicing doing the k plus 1 term. So this is not a proof. It just says find p sub k plus 1. So if this is p sub k, I don't know why it's underlined. But if this is p sub k, what do you think I would do? I wanted to find the p sub k plus 1 term. You agree that I'm just going to change every k to k plus 1. So this would become k plus 1 squared. And you can just do this in your head, but I'm actually going to work it out. This k would become k plus 1, but there's already a plus 1 there. Squared. All over 4. So if you have p sub k, all you have to do to find the k plus 1 term is change every k to k plus 1. Which means you don't have to FOIL this out. Sometimes you guys go crazy FOILing things out. That would be silly. I'm just going to leave it like this. K plus 1 squared. Is it okay if I change this to k plus 2 squared? I don't like the flashing marker. That's the point.
Yeah, from that one.
There is a question on your homework like that, so don't try to prove that when it says just find k plus 1 or k. Okay, ready to do a proof? Okay, sounds good. Come on, smartboard, I need you to wait. So here we go. Use math induction to prove that this is true. So every one of these problems, they're going to give you a pattern, and they're going to tell you what the sum of the nth terms equal. So they're telling you the pattern, 3 plus 7 plus 11 plus 15. This is the nth term. And they're telling you if you add all those up, it equals this. We're going to prove that that's true. All right? And every time we have to do 2 steps. Step 1, we're going to prove that p sub 1 is true, which is the easy step. All we're going to do is plug 1 in for n into these formulas and show me that they equal each other. It will always work. They will never give you one that doesn't work.
You won't, right? Yeah, you won't.
I won't. I'm going to show my work. I'm going to plug 1 in for n, and I'm going to say that equals 1 times 2 times 1 plus 1. Just to show you where it's coming from. And so that would be 4 minus 1, which is 3. 2 plus 1 is 3 times 1 is 3. 3 equals 3. Hooray, we did step 1. So is the part that people always dislike. Um, but when I was in college, I took a class that was all proof class, maybe the hardest class of my whole life, Math 380. And there's a really short lady, so about this tall, that taught my class, and I always remember her teaching this. But we need to show that p sub k plus 1 is true. Right now, there is no p sub k, right? There's p sub n, right?
Yes.
Yes. So we need to change this to p sub k. So I'm going to say, let's assume that p sub k is true. People dislike that because they don't like to say assume, because you know what they say about assume, right?
What is it? What is it?
I don't know. You ask your mom. So what I'm going to do is I'm just going to change this to p sub k instead of n. So I'm going to say p sub k equals, everything's the same except for n's are turned into k's. 3 plus 7 plus 11 plus 15 plus dot 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 plus 4k minus 1 equals k times 2k plus 1. All I did was change n to k. I've always done this in 2 separate spots because my paper's never long enough for me to do this all at once. Last year, people said, why don't we just do this all in one line because it made more sense. So I don't know. I like to start with what I'm looking for and then go back, but then you'd let me know in a minute if you want me to do it the other way. Here's what we're trying to show. If p sub k is true, is p sub k plus 1? What happens when I do the next one? So we need to show the k plus 1 term for this. We need to show the k plus 1 term on this side, and we need to show that they equal each other. So would you like me to do this all in one line, or would you like me to break it up? Try all in one line? All in one line, all right. That's what they said last year. Sometimes it's really won't do that way. So the k plus 1 term, 3 plus 7 plus 11 plus 15 plus dot 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 plus, this is the k term. So if I add the next term to this sequence, I'm going to just change that to k plus 1. So notice this side is the pattern. Each one, like this is the first term, second term, third term, fourth term. This is the kth term. So then this is the k plus 1 term. All I've done is change this to k plus 1. Kind of sort of with me?
Equals k times 2k or whatever.
Now on this side, I also need the k plus 1 term, but this is the sum. So I don't have to include this plus k plus 1. On this side, I'm just going to change this to k plus 1 times 2 times k plus 1 plus 1. And again, think about what I'm saying here. This side, I'm adding the very next term. This side is the sum. So the sum is just changing k to k plus 1.
What does extra plus 1 stand for?
Every time there's a k, I'm changing it to k plus 1, because now this whole thing equals k plus 1. See, in the way I've always done it is I do this side first, and then I go back and do this side, and I show that they match up. But we'll see. We'll see how this goes. Maybe I'll try it the other way next time. So everyone got a k? Sorry. Okay, let's work on this side first. I think this is the easier side, which is where I always work. Can we simplify this?
Yes.
Yes.
I just guess that actually how.
Over here, like, forget about the pattern part. Over here, I could just distribute, right? Like, I could get 2k plus 2 plus 2. It's a good voice, right? K plus 1 times 2k plus 4.
You can take a break. Right there.
I don't know, because I can add. That would be plus 1 plus 3. And I could even FOIL that out, right? Say 2k squared plus 3k plus 2k would be plus 5k plus 3. That's just placing k with k plus 1 and boiling it out. I feel like I'm over the hump. Like, fever was downstaying. I'm on the mid. There were like 60-some people at it yesterday. I don't think it's just me that's doing it. I don't know. I haven't got the email yet. Mr. Bucket's sick. Okay. He wasn't here yesterday either. Okay. We have to make this side match this side, and this part I find a little bit more difficult, but again, it's the same every time. Do you agree or disagree that this whole part, right, this whole entire part is just equal to p sub k?
Yes.
Because this is exactly what we said up here that p sub k equaled. So I can say that p sub k plus 1 is really just equal to p sub k plus that extra part, which I'm going to go ahead and say is 4k plus 4 minus 1, because I'm just going to distribute that. That's here. The rough parts are walking off right. Might just want to start on the next.
Yeah, you might just start the class.
Maybe.
Don't want them to they're on the stuff right now. When are we going to use this one?
On the 10th on Thursday.
Why? Why? What after that?
I don't care after that. On their final exam.
So he doesn't care about that. Yeah, he doesn't care about it. It's like, wait, how do I, balance a checkbook? All you have to do is
Assume that p sub k is true. Just go with that. P sub k. Do I know what p sub k adds up to? I do. If I go back here to p sub k and I follow all the way down here, I know that p sub k adds up to this. So I can take this and I can plug it in right here to p sub k.
Wait, no, that's
What?
on that side.
That's okay. That's what p sub k equals, though.
too many K's. I don't know. That's okay, but it's a piece of K. A piece of K is true. What am I doing? We should just skip the class.
Yeah.
I wish I could make this up.
It's the drugs talking, guys.
If my throat hurts so bad, guys. If p sub k adds up and equals this, it's just substitution. If this is p sub k and it equals this, I can substitute that in. I'm allowed to. It's just math. Crazy math, but it's math.
If there was any goal about this stuff, you should think it right now.
So I'm going to plug that in. I'm going to distribute it at the same time if you're okay with that. K times 2k is 2k squared plus k plus 4k plus 4 minus 1. And then this is where the magic occurs, kids.
Wait, you forgot a K. Oh, no, you didn't. You just distributed.
Look, Dylan, it's all coming together. What happens now when I simplify this? This is supposed to
No,
be
it's not the same thing. All this crap.
I get 2k squared, and k plus 4k is 5k, and 4 minus 1 is 3, and that equals what we were trying to get. Which means, hooray, we proved it.
Who can't? It was like math haters, like prove it. You can't prove it.
Proved it. That's what we're trying to do.
What are you thinking?
Wait, all
Have
that
some
is
faith,
say that.
Miss Dixon.
What?
Have some faith. You have to prove it. Have some faith.
Mrs. Dixon,
Yes.
it always works every single time. Why do you need to know how to test it?
Amen to that.
Is it ever going to be no? Like, is there ever
There could be no ones, but I'm not going to give you any that are no, because I don't want people. No, I will check your work. I mean when I check it.
Tell what you're teaching us.
Will you take off the lack of work?
Yes.
Take out the answer?
Yes, I will take off for lack of work. Because it's a proof. I don't know who you had for geometry and how they graded, but the proof part, the bottom step is the least important step of the proof. proof. It's all the steps in between that prove the problem. Let's do another one. Oh, look. So people always complain, when am I ever going to use this? And there's really no, like, you're never going to use this, except for it's kind of a cool thing to think about of how you can prove something that's true. How could you prove that something goes on forever adds up to this? You can't really prove it unless you do this. That's how. So on one of my calculus listservs, because I'm that cool and I'm on a calculus listserv and I get lots of emails from calculus people, like a discussion group, someone said that they tell their students this about proof by induction. If you were trying to prove that you could climb on a ladder with infinite rungs, you will do the following. Step 1, you will prove that you can get on the ladder. That's proving the first step. Right? Prove that 1 is true. Step 2, I will show that if I'm on any rung, the kth rung, then I can go on the next one above it, the k plus 1 term. And if I can prove that the first, I can get on the ladder, and if I can prove that no matter where I am on the ladder, I can step up to the next ladder, then that proves I could be on a ladder that has infinite rungs. Huh? You couldn't add up this sequence forever either because you would die. But we can prove that it's true.
Well, but you could, die and then you're told.
Oh man, this one looks exciting. Let's do this one.
No, we're not doing this.
We are.
Olivia just asked you guys to. Wow.
I told you that was not good. Step 1.
Assume C equals K.
Prove P1 is true. It's just steps. It's the same steps every time. The numbers just change. And I'm just going to plug 1 in. And I get 1 plus 1 over 1 equals 1 plus 1. Is that true? I'm just plugging in 1 for in right here. And I get 2 equals 2. Checkaroo. Checking is my favorite part of proofs. It's a virus, honey. Antibiotics don't help. Step 2. Assume P sub k is true. The reason that we changed the P sub k is that the nth term is like the last term. So we want some term in between. You really could use any letter you want. I just use k. So I'm going to go through and I'm going to write P sub k. Because we need P sub k because we have to sub in for P sub k later. So just going to go through, and you can be a little lazy sometimes if you want. You can say 1 plus 1 over 1 plus, or times 1 plus 1 over 2, and then I'm just going to go ahead and say dot, dot, dot. 1 plus 1 over k equals k plus 1. And here's the whole idea with proof by induction. If I look at the k plus 1 term for this, and the k plus 1 term for this, they should equal each other. And if that's true, then I've proved it's true for the whole thing. So, we're going to do this all in one step. It's a new way to roll here. If this is P sub k, I want the next term. What would this next term be?
K plus 1 plus 1.
We're on this side.
1 plus 1 over K.
1 plus 1 over k plus 1. And notice we're multiplying on this one. We're not adding, so it's not adding this, it's multiplying. So all I've done is change k to k plus 1 and do that next term. And then on the other side, Grady was so excited for this side because he knew all we're going to do over here is change this k to k plus 1, which I'm going to say is k plus 1 plus 1, which is really just k plus 2. Which means here's the goal. I want this side to also equal k plus 2. That's how I know I did it right. If this side doesn't equal k plus 2, I did something wrong. You could just make up a bunch of work and then put k plus 2 and hope I don't notice, but I'm going to notice. Same. I'm going to notice. It's the same every time, though. every time. Dang it. This, everything but the k plus 1 is going to always equal piece of k. So I can say this equals piece of k times 1 plus 1 over k plus 1. It's really important that you show your steps in the proof. A lot of times people jump straight to this, right? They write this and then they jump straight to this. I need to see that step in between. It's a proof. I got to be able to follow it and see where piece of k came from. And then every time, do I know what piece of k already equals?
Yes.
I do. Here's piece of k and go all the way to the end. And what does it equal? K plus 1. That is always what you are going to sub in for piece of k. You don't have to draw that arrow on your real homework. I just find it helpful in your notes so that you can go back later and be like, where did that come from? So I can say that this is k plus 1 times 1 plus 1 over k plus 1. Once you sub in what piece of k is, now it's just simplifying it. We want to get k plus 2 out of this. So, can I do some good old common denominator stuff over here? Oh man, that's so exciting. This is 1 over 1, right? So could I say if I multiply this by k plus 1 over k plus 1, I would get k plus 1 over k plus 1 plus 1 over k plus 1. I'm just getting a common denominator between like 1 and k plus 1, so I'm just making it k plus 1 over k plus 1, so I can add those together. And so on the top, if you add that together, you get k plus 1 plus 1, which is k plus 2 over k plus 1. And then what happens? You can cancel that out, and you get k plus 2. Is that what we wanted?
Yes.
Yes, and look, I kind of far apart this time. So I like to draw a little arrow like this, and I like to say, check. Or sometimes I like to put a smiley face. Smiley face. Or sometimes you can do like this. Is it like this, or is it like this? I never know.
What does that mean?
I don't know. Proven.
What? You should get stamps.
Or Dado Seacrest is very offended because last year I said, or if you're left-handed, you can make your check marks like this. And apparently not all left-handed people make backward check marks. But I had a left-handed teacher. I had a left-handed teacher in high school, and he always made the check marks backwards, and he said it was because he was left-handed, and it was much easier to make your check marks backwards. So Dado Seacrest thinks I hate left-handed people,
Well, probably do that.
but he would always check mark our papers backwards. So you could make a backward check mark if you want. See, that's not the worst thing in the world, right?
Just the worst thing in the chapter.
Maybe the worst thing.
And probably.
So I have some homework for you. Only 4 problems.
Yeah, only for about 10 minutes each.
2-minute whole time. Yeah. That's a solid point.
Yes, 4 fast.
Number 10 is not a proof. Ooh. Number 10 just says, find piece of k plus 1. So you don't have to actually work it out. You just practice doing that. So that one's not for that. But the other ones, you actually have to follow that. My advice is start with number 1 so that I can help you if you need it. Number 15 we'll probably do together tomorrow, maybe. Still wrong this one. 15's the worst.
15, and she'll help us with 1.
15's the worst. You do one right now.
Let's get 15.
You can do it, but there will be a proof by induction question on your test.
Let's try to work. Why this is shows how
But probably like 8 points.
shows how we can know rules and math. That's what our life application is.
what the book says, why you need to know proof by induction. This is good to just think about things, you know?
That is a quick
Alert. Students tend to find mathematical induction to be a difficult topic. There is confusion about what is assumed and what needs to be shown.
Because I just see that it's all. It's for assuming.
Book says the principle of math induction is a valuable technique for proving combinatorial formulas.
They made that word up.
I think it's just important to know that